Okay, today we're going to talk about representing functions as graphs. So on this little box, or in this little box on the left, we're going to go ahead and fill in the blanks. And it says you can use a graph to represent a function. Given a table that represents a function, each corresponding pair of input and output values forms an ordered pair of numbers that can be plotted excuse me, as a point. Okay, and then the x coordinate is the input, and then I don't really know what happened to my other blanks. The y coordinate is the output. Okay, so ordered pairs up here, I even wrote it out, always go input, output. Okay, x comma y. Input is x, output is y. Okay, so kind of what we dealt with yesterday are tables, where if our x was 1, our y was 2. If our x was 2, y was 3. Okay, if our x was 4, y was 5. And so to write that as an ordered pair is 1, 2, because it's x and then y. This pair would be 2, 3. This would be 4, 5. And then if you guys remember graphing, okay, you always put the input or the x along the bottom and then the output or the y along the side. So for this ordered pair 1, 2, it was over 1, up 2. This is the ordered pair 2, 3, 4, 5. So down here it says, well, graph the function y equals 1/2 x with a domain of 0, 2, 4, 6, and 8. Okay, so the first thing that we're going to do is we're going to create a table. Okay, so I'm going to come down here and we're going to have our x and our y, right? Our input and our output. So it's giving me inputs of 0, 2, 4, 6, and 8. Okay, and my y, it tells me in the function, is half whatever x is. So if x is 0, half of that is 0. If x is 2, half of that is 1. If x is 4, y is 2, 3, and then 4. Okay, and then we're going to label our graph. So I'm going to pick this color. So I'm just going to come along here. Oh, that's dead. Try this one. Okay, so remember this is always your y-axis. Then horizontally, this is always going to be my x. So I have my x and y-axis. Okay, so my first ordered pair is the pair 0, 0. So 0, 0 is right there. Okay, then my next ordered pair is 2. So remember these are 1, 2, 3, like I'm just counting the lines. So the next one is 2, 1. And then 4, 2, 6, 1, 2, 3, and 8, 1, 2, 3, 4. Okay, and those are my dots. I'm not connecting them with a line or anything like that. Okay, I could have made this bigger. This is just kind of what I printed, but you get the idea, right? That this right here is 0, 0. This is 2, 1, 4, 2, 6, 3, and 4. Oh, I messed all this. Oh, no, just kidding, just this one. 8, 4. Okay, and you do not have to label the ordered pairs. I was just trying to show you. Okay, and then the next one is, let's see, graph the function y equals 2x minus 1 with a domain of 1, 2, 3, 4, and 5. Okay, so we're going to make our table again. So this time I'm going to do x and y, and then, oh, you can't even see that. There we go. Okay, and then my x's are 1, 2, 3, 4, 5, and my y's, let's see, so 2 times x minus 1. So 2 times 1 is 2, minus 1 is 1. 2 times 4, or 2 times 2 is 4, minus 1 is 3. 2 times 3, and I'm getting this from up here. 2 times 3 is 6, minus 1 is 5, 2 times 4 is 8, minus 1 is 7, and then 2 times 5 is 10, minus 1 is 9. Okay, so again, I'm going to label my axes. So down here, this is the y, and this is the x. Okay, so I had the point 1, 1, and then when x was 2, y was 1, 2, 3. When x was 3, y was 1, 2, 3, 4, 5. When x was 4, y was 1, 2, 3, 4, 5, 6, 7. And when x was 5, 1, 2, 3, 4, 5, it was 9. And there we go. And again, I'm not connecting them with lines or anything like that. Okay, let's look at the next one. It says, the table shows the average score, S, on the math section of the SAT in the U.S. from 1997 to 2003 as a function of time in years since 1997. Okay, so in the table, 0 corresponds to 1997, right? Because if you think about it, if it's 0 years since 1997, then it's 1997. So this would be 98, 99, 2000, right? 2001, 2002, 2003. Okay, so let's look at how to graph this. Okay, so the first thing is I'm going to put down on the bottom, right, my input, which is years since 97, right? This is my x value. Okay, input always goes on the top, or sorry, not on the top, on the x-axis. Okay, and then up the side is going to be the average score. Okay, so when I'm trying to kind of like make my like intervals here, okay, I don't need to start at like 100 or anything. I'm going to start, essentially, I'm going to go ahead and start it. Let's see, all of my scores go from my lowest is 511 and my highest is what, 519. So I'm going to do, first I'm going to make my axes like this. Okay, and now what I'm going to do is I'm going to do what's called a break. Okay, so I'm showing that we're kind of, there's some data in between here that we don't need. And then I'm going to go 5, 10. Let me think here. 5, I'm going to skip 2. 12, 14, 16, 18, 20. Okay, so 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 5, 20. And then years since 1997, I'm just going to go through 6. So I'm going to do 0. I'm going to skip 1, 2, 3, 4, 5, 6. Now I can take my data and I can plot it. So when there were 0 years since 1997, the score was 511. So 0, 511. After 1 year, the score was 512. Oops, change here. After 2 years, it dropped down to 511. I am messing this up because I'm forgetting that I'm skipping. Okay, after 3 years, it was up to 514. So 3, 10, 11, 12, 13, 14. Then after 4 years, it was 514. After 5 years, it was 16. Yep. And then after 7 years, oh, did I skip? Let's change that to 6. That should be a 6 up there. My bad. Okay, and after 6 years, it was up to 519. Okay, so ignore these two guys down here. Okay, but that is our data on a graph. Okay, so the next thing we're going to do is we are going to write a rule when we're given the graph. Okay, and then we're going to identify the domain and the range. So the first thing we're going to do is we're going to go ahead and make a table. I think that's sometimes the easiest way. And after we get that table, we're going to look at the relationship between x and y. So I'm going to go ahead, x, y, and I'm going to look at my ordered pairs. when x was 1, y was 3. This point, when x was 2, y was 4. When x was 3, y was 5. And when x was 4, y was 6. So what relationship do y'all see between x and y? Like I know 1 times 3 is 3, but is 2 times 3 4? No. So 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2. So whatever the x is, I'm adding 2. So the relationship, whatever the y is, whatever the x is, I'm adding 2 to get the y. So the y is always 2 more than the x value. Okay, and then if I'm being asked to identify the domain and the range, okay, the domain is 1, 2, 3, 4. And the range is 3, 4, 5, 6. Okay, so all of this goes with this top one. Okay, so let's look at the one next to it. Okay, so I'm going to make my tables of x and y. So here, when x was 0, y was 5. When x was 1, y was 1, 2, 3, 4. When x was 2, y was 3. And when x was 3, y was 2. And when x was 4, y was 1. Okay, so let's look at it. How can we figure out what the relationship is? What do you think? Okay, so did you figure it out? Okay, so let's look at it. You're like, well, I'm adding 5. I'm not adding 5. I'm not adding 5. Okay, so what could it possibly be, right? It's not times 5. So what do you notice about all of these numbers? Do you notice anything? What's 0 plus 5? What's 1 plus 4? What's 2 plus 3? What's 3 plus 2? And what's 4 plus 1? They're all adding up to 5, right? So x plus y is 5. But if I need to write it as y equals, I'm going to subtract this x from both sides, and I get y equals 5 minus x. Okay, so 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 4 is 1. So if you don't see an obvious relationship between like adding 5, adding 5, adding 5, or times 2, times 2, times 2, look to see if there's a relationship between like these add up to 5, add up to 5, add up to 5. Okay, and then the domain is 0, 1, 2, 3, 4, and the range is 5, 4, 3, 2, 1. So let's come down here and look at this one. So I'm going to make my table. So there's x and y. So my x value here is 1. My y is 10. When x is 2, y is 15. When x is 3, y is 20. And when x is 4, y is 25. Okay, so what would the relationship be? What could it be? Okay, so let's look and think about what we learned last year too. Okay, how much is this going up every time? How much are we increasing it by? This is going up by 5, right? Up 5, up 5, up 5. Okay, if I backed this up one number, what would come before 1? 5. So my function is y equals 5x plus 5. Okay, so all I did, okay, was take 5 times 1 is 5, plus 5 is 10. 5 times 2 is 10, plus 5 is 15. 5 times 2 or 3 is 15, plus 5 is 20. Okay, I don't know if you remember last year. I'm going to write it up here. Okay, but we did this thing where it was like, when we wrote functions, y equals blank, x plus blank. And the first blank is how much y is changing. And in the second blank is what y equals when x equals 0. Okay, so pause the video for a second if you need to write that down. Okay, and then I'll show you how it applies to both of these. Okay, so look at this example. How much is y changing every time? It's going down 1. Okay, so let's rewrite this. Y equals blank x plus blank. So it's going down 1 every time, and when x was 0, what was y? 5. That means the exact same thing as this right here. Okay, so look at this example. What's happening every time? We're going up 5, up 5, up 5. So that's where this 5 came from. I don't have x as 0, but I have x as 1. So if I backed it up to 0, what would come first? 25, 20, 15, 10, 5. Okay, so let's see if we can use that on this one. So y equals blank, x plus blank. So what is happening every time? Oh, let me make my chart first. X, y. So when x is 0, y is 1. When x is 1, y is 1.5. When x is 2, y is 2. Okay, so let's look at it. So in this first blank, it's how much y is changing. So it's going up 1, 1.5, 2. So that's going up by a half. Okay, and then the next question, or the last blank, is whatever y is when x is 0. And we're given that. When x is 0, y is 1. So y equals 0.5x plus 1. Okay, so I wanted to give you kind of like all the ways to look at it. Okay, you can make the table, right? And sometimes you can just recognize the pattern from the table. Y is equal to 2 more than whatever x is. If it's less obvious, then you can use this method up here.